Now that the Luna client is installed, the next step is to let it safely communicate with the Luna HSM. In this topic, you'll see how trust is established, how partitions are assigned, and how applications authenticate before any key operations take place. You've already seen what HSMs are, how Luna appliances are structured, and how to install a client and talk to a local HSM. Now we shift to trust, establishing authenticated secure connectivity to specific HSM partitions. Once that's in place, we'll be ready to manage keys throughout their lifecycle. Before any keys or operations are exposed, the Luna client and the HSM must prove their identities to each other. The client validates the HSM certificate so it knows it's talking to the genuine device. The HSM validates the client's certificate, so only approved hosts can connect. When both identities are confirmed, a secure TLS or NTLS channel is created. Only after that does partition-level authorization decide what that client is actually allowed to do. For a client to participate in this trust model, it needs its own digital identity. You start by choosing a stable client name that aligns with your organization's naming rules, because this name will appear in logs and policies for years. Then you generate a certificate and private key on the client host, store them in a secure, well-documented path, and protect that private key carefully. It is the cryptographic proof of who the client is. To let the Luna client trust the HSM, it needs the appliance's server certificate, obtained through your approved admin process. Copy that exact certificate onto the client and place it in the trusted server store or directory. Then confirm that the hostname or IP the client uses matches the certificate's identity. Any mismatch should be treated as a potential attack. When you're done, rerun the client verification tools to confirm trust. Once the client's identity is in place, the HSM needs to recognize it. The administrator registers a client record on the HSM, tying together a client name, its network address, and the uploaded certificate. Those identifiers must match what the client software uses, or mutual TLS will fail. Think of this as the gatekeeper step. Only registered, approved clients are allowed to talk to the HSM. After certificates are exchanged and trust is configured, always validate the secure path before blaming your application. Run a tool like VTL Verify to confirm that the HSM is reachable and that the secure channel is actually up. Then use VTL listServers or your equivalent to check that the correct HSM ID appears. Remember, you'll only see partition or slot entries once. Both trust is established and partitions are assigned correctly. Registering a client only confirms who it is. It doesn't define what it can use. That's where partition assignment comes in. The administrator maps each trusted client to specific HSM partitions, and those partitions appear as the only usable cryptographic slots for that client. A client might need multiple partitions or just one. The key principle is least privilege. Assign only the partitions that particular application truly requires. You can think of access in 3 layers. First, network trust. Can the client even reach the HSM over a secure, mutually authenticated channel? Second, partition assignment. Has the administrator granted this client visibility of a particular partition? Third, partition login. The application authenticates as a crypto officer or crypto user, using strong credential handling to actually perform operations. Most it connects, but I can't use keys issues show up in this last layer. To get an application talking to a Luna HSM, work through a clear sequence. First, discover which slots and partition labels the Luna client exposes. Then lock in the exact one your application should use. Next, configure your middleware to load the Luna cryptographic library or provider. After that, wire in authentication using a secure secret management pattern, never hard-coded passwords. Finally, run a simple test operation to confirm that the login session works before you move real workloads. Luna's client behavior is only as reliable as your environment hygiene. Treat configuration as code. Know exactly which files and directories define your client on each platform, and keep those locations consistent across dev, test, and prod. Verify that certificate paths, server entries, and partition references are all valid and current. Match runtime library paths to the installed client version. And resist ad hoc edits. Only change configurations using documented, repeatable procedures. When something can't reach the HSM, don't jump straight into application code. Work from the bottom of the stack upward. First, prove basic reachability: IP, DNS, routing, and firewalls. Next, confirm that mutual TLS and certificate trust are correct. Then check that the client can see the expected partitions and slots. Only after a clean partition login do you test cryptographic operations. Fix whatever fails before moving to the next layer. A typical ticket sounds like this. We installed the Luna client, but the application can't see any HSM slots. Before touching the HSM, treat it as a network problem. Can the client resolve the hostname? Can it reach the HSM IP and ports directly, without a proxy or unexpected NAT? Loop in the network team early. Misconfigured firewalls cause more issues than the HSM itself. When something breaks, start by mapping the symptom to the right layer. Certificate errors usually mean a name mismatch, a missing trust chain, or an expired or replaced certificate. Confirm SANs and trust stores. If no slots appear, check that the client is registered and assigned to the correct partition. For login failures, verify the role, PIN, and that the role isn't locked. Then correlate everything using client logs and HSM admin or audit logs. You've now seen how a Luna client becomes a trusted participant. First through certificate-based mutual trust, then by assigning it to the right partition, and finally by logging in with appropriate roles. With access firmly in place, the next step is to focus on keys themselves: types, attributes, policies, and full lifecycle management.